Hi, this is Ron Wade with IDT. Welcome back to our multi-part series on full-featured PCIe clocks. This particular presentation is part 4 of 5 covering clock multiplexers. So the 3.3 volt full-featured PCIe clock mux is the 9DBL04, and it supports all of the proposed upcoming PCIe clock standards, which include Gen 4 common clocking and Gen 2, 3, and SRAS. It has integrated terminations for either 100 ohm environments or 85 ohm environments, so you never need to add a termination resistor. It has 2 switching modes, which I'll come back to in a second. It's packaged in a 4x4 QFN, and with this 3.3 volt device we can factory OTP customize the part for you. For instance, maybe you want a different slew rate or a different output amplitude, or you want your output enable to be active high instead of active low. These are all configurable. They also have 1.5 and 1.8 volt parts in the family as well. So the 3.3 volt device, again, all the muxes have 2 switching modes. One is called glitch-free, the other one is called asynchronous. Glitch-free is not a hitless switch mode, but it is a glitch-free mode. And what we mean by that is you will have an output running on one of the clocks, and when you are in glitch-free mode, you switch to the other input. The output will stop. So the currently selected clock will stop. There'll be a gap of 2 or 3 clocks, and then the new clock will start up. So that is what we mean by glitch-free switching. No runt pulses, no slivers of clocks, but you will have a little gap in the output as the part internally switches over and synchronizes. The asynchronous mode is for those cases where you only have one input clock at a time present, and or you have a strapping mode where if the board is plugged into one place, you use clock A. If it's plugged into another place, you use clock B. In that case, you want to use the asynchronous switching mode. So the 76 milliwatts at 3.3 volts is significantly lower than our legacy parts. The integrated terminations save you 16 resistors on your BOM and 28 square millimeters of board area. And then with the compatibility with the future PCIe specifications, you can do this design with this part and amortize it over multiple generations of your system. So the clock multiplexers, basically all of them have 2 inputs, and then in the DML04 family, for instance, we have 4 outputs, and at the 1.5 and 1.8 volt levels there are 1 output parts, so 2 in 1 out for the DMV and DMU devices in a 3x3 QFN, and then the 4 output devices are available at all 3 voltages in the family, 4 outputs in a 4x4 QFN, and again the 3.3 volt parts Gen 1 through 4 compliant. We're looking at that compliancy for the 1.5 and 1.8 volt parts, just as we are looking at the SRNS and SRIS compliancy for those devices. Pin compatibility across the 3 members of the family, the 3 operating voltages for the 4 output, and at the 2 output as well. So why would you use a 4 output DML04 as opposed to a 55706 or a 5V41067, which are IDT's legacy parts? Well, performance is one thing. You've got virtually no additive jitter to the PCIe specifications. You've got a roughly 64 millimeter square area down to 36 square millimeters of area, so you're saving almost half the board space. No termination resistors, and you're going from 264 milliwatts to 76. So to summarize that, that's up to 500% lower phase jitter, additive phase jitter here, 58% less area, up to 75% less power. 16 resistors get taken off the BOM. The 1.8 volt and 1.5 volt parts can actually save even more power if that is more concern to your system. So really, go for the new parts. So thank you. That concludes part 4 of this 5-part series.